Hello, in today's video we are going to talk about inheritance. So one of the core fundamentals of programming is something that is called inheritance. And essentially what inheritance is that an object, such as any object that we talked about earlier, extends all of its logic and data to another object. And in most cases, when we are talking about inheritance, we are actually talking about a relationship between two objects. And the most common relationship is a parent-to-child relationship. We'll go ahead and talk about what that is next. So essentially what a parent-to-child relationship is that everything the parent has, the child also has. That goes for all of its logic, all of its attribute, everything that the parent has, the child also has access to those logic, to those attributes that the parent has. But it only goes one way. You can only go from parent to child. You can't grab everything from the child when you are the parent. So that is the downside of this relationship of inheritance. What parent to child is the one-way data flow. Something that you can do from the child end is that you can also modify or change or even override some methods from the parent with the passed down logic from parent to child. So using Ruby, let me show you how inheritance will look like. So the first thing you need is some sort of a parent. And a parent in most cases would be some sort of a class or some sort of a way to represent an object. Then afterwards, depending on your programming language, when you are using an inheritance, they would have different symbols or different syntax for you to use to signify inheritance. So inside of Ruby, this little caret here, this little greater than sign, means that you are inheriting from whatever is on the right-hand side. So this child is inheriting everything from the parent. Everything that the child has is accessed within the child. But everything that what the parent has is accessed within the parent and the child. So that is one of the things with inheritance, is the access of information and logic between the objects. Let's start off by giving you examples of actual classes and actual objects with inheritance. So here we have a class or object of animals. And animals might have some attributes that all animals have and some logic that all animals have. As you can see here, we can stem off of animals. So bird inherits everything from animals. So bird is technically still an animal. And it also does things that a bird can do. And over here, with this child, we are also inheriting from animals as well. It has everything an animal has, and it also includes everything this fish class has as well. And you can go however many levels deep. You can even go one more level deep, like a parrot inherits from bird, which bird inherits from animals, and animals is the main element here. So with this, you could have access to everything a bird has, and a bird has access to everything an animal has, and the list goes on and on. You can be more simple or complex with that. Another way to represent relationships as well as inheritance, especially with the parent to child relationship, is something with a tree diagram. And tree diagrams, you can do them as complex or as simple as possible. But the main thing is that when you have a parent, you put them up here at the root. At the very top, that is the root element. And that is usually where you start off with. And usually what the parent is starting off with at the root. Then after that, you can see how many children that animal has. So this particular object has two childs. They have fish and a bird. Everything an animal has, a fish has. Everything an animal has, a bird also has. And then we can also go however many deep. We can see that bird is a parent of parrot. And parrot is the child in this case. And you can also say that that's the grandparent, things like that. And something else is that with these type of relationships, they have different meanings and have different way of accessing data. So for example, with animals, it's one way, right? You can only go downwards. So you can grab animal information in the birds, and you can also grab the bird information in the parrot. You can't just skip all the way from animals to parrot or from fish to parrot because there is no direct correlation or direct connection with that. You can also see that with fish and bird, there's something called sibling elements. So with sibling elements, they share the common parent. And they might have access to the same exact logic and the same exact attributes with the parent that they all share. So, diving deeper into inheritance, with the parent and child, everything the parent has, the child also has. That includes logic, including methods. So, with methods, I can call the breathe method within the bird class as well as the animal class because of the inheritance. So, I'm able to use this single method in both cases. And that might be useful for me to use in both cases because both the animals as well as the bird both breathe. But sometimes you may want to change it up a bit. For example, every animal is able to speak, but some animals speak differently. In some cases, you may need to update it or override the method, the logic that you want to do. That way it fits into your context. So, for example, not all birds talk. Well, technically they do, but a better thing to do is that all birds chirp. So, as all birds chirp, if you want to override any parent method, you would just need to have it be the same exact name as well as the same exact spelling. That way it will replace it with whatever it is the child has. So that is overriding methods or altering methods. You can do it like so. But sometimes you don't want to change the whole thing. Maybe you want to just modify it just a little bit. That's where you can bring the keyword super. And you'll probably see super a lot. Essentially what super is that it brings down all of the information from parent to child within that context. So if I want to bring down all of the speak here, I can just bring it down with super. So usually if you want everything from the parent, you would use the keyword super here. So this really shows what exactly we're able to do. So if we were to create a new instance of a bird, we can see that the bird also breathes. Even though that is defined in the parent element, I have access to it because of inheritance. And if I do a speak here, since I'm overriding it with a child, it does the one that is inside of the child. Now let's go into a practical example, because it might not be realistic to do animals and birds and fishes. So a practical example would be that we have a class of user. And user could have a lot of things such as email and password, and the ability to change password and do whatever it is you need to do with the user. And let's say that inside of your application, you also have another object of employee. An employee might have the same attributes as user, but it will be changed or added onto even additional attributes that the employee needs. If that's the case, then it will be its own class. And I don't want to be redundant here. I shouldn't say the employee also has email and password, because that's just being redundant. You're not being dry in this particular case. A better thing to do is use inheritance. So with inheritance, I can grab everything from the user. So I can grab the email and password if I needed to. And also I can grab information from the employee, such as the ID and the day that the employee started. And with this certain type of example, I'm able to do whatever it is I need to within the employee and user context. So I'm able to clock in as an employee and check all my attributes for my email as well as when I started, even though they are defined at different areas, at different classes. Because of the inheritance relationship, we have access to both of them. And here I can also call a method of change the password to change whatever password I need to have. So this is a much more practical example of how we will be using inheritance. Is that we need to have certain objects inherit certain attributes because we want to be dry, and also we want to maximize all of our classes as much as possible. So just to wrap everything up, essentially when we are talking about inheritance, we are actually talking about a parent-to-child relationship. And everything the parent has, the child also has. And it usually just goes one way. And the child is able to change the logic of whatever the parent has, and you can use anything that the parent has as well. So that is pretty much it for inheritance. If you have any questions, go ahead and leave a comment down below, and I'll see you in the next video. See ya!